1.4 quadratic equations. Now, this section I'm going to break up into 3 separate videos, just because it's going to allow the videos to be a little shorter and make it easier to reference parts of it later. You'll see that the breakup of it will be done in such a way that you may want to refer to the second video, or you may want to refer to the third video again, but maybe you don't want to come back to this first one because you consider this first one a little simple. So we're going to break it up to those 3 pieces. So starting out with quadratic equation, well, what is a quadratic equation? A quadratic equation in one variable is an equation that can be written in the form ax squared plus bx plus c is equal to 0. So that is what we consider a quadratic equation. Basically, it's a second degree equation. Remember, you look at the terms and you go for the highest degree term, and that tells you the degree of the equation. So it's a secondary equation, and obviously a secondary equation is any equation that has a squared term and no higher degree terms. So when we're dealing with quadratic equations and solving quadratic equations, we get into standard factoring. And we're going to use the zero product rule. Zero product rule is that rule that says if you had a times b is equal to 0, then a equal to 0 or b equal to 0 will make this statement true. So either a is equal to 0 or b is equal to 0. Which means that if we factor this, then we set each factor equal to 0, we can solve each of those to get our values for x. So that's our first method of solving quadratic equations. So if I have x squared plus 5x plus 6 is equal to 0, and I want to solve this quadratic equation, I can factor this side. Now realize when you're factoring quadratic equations, you have to have one side of the equation equal to 0. You can't factor x squared plus 5x equal to 6. You'd have to have that 6 moved over here, and then in that case make it minus 6. But you can't do that. So whenever we're factoring quadratic equations, to use the zero product rule, we need to have 0 on the other side. And actually, anytime we're solving a quadratic equation, we're going to start with that 0 on the other side just to put everything in where we need to be. So we can factor this, and remember the first thing we look at with a quadratic expression, if we're going to factor it, is, first of all, is the leading coefficient 1? If it is, then we can just say, okay, are there 2 numbers that multiply to 6 and add to 5? And those numbers are 2 and 3. 2 times 3 is 6, 2 plus 3 is 5. So then we can just say this is x plus 2 times x plus 3 is equal to 0. Now we can set each of these equal to 0. X plus 2 equal to 0, x plus 3 equal to 0. Subtract 2 from both sides. X equal to negative 2, subtract 3 from both sides, x equal to negative 3. So for this quadratic equation, the solutions are x equal to negative 3, negative 2. Now why did I go negative 3, negative 2 instead of negative 2, negative 3? I went in numerical order, right? From least to greatest, doesn't matter. If you say negative 2, negative 3, who cares? It's the same thing. So either one is valid, but that's our idea, is that if we can factor it, then we can set each of those factors equal to 0, solve and find out what value gives us that, and that will be the solution to this. And we could, of course, check this and say, well, if I put negative 2 in here, I'm going to switch to the red marker for this. If I plug in negative 2 squared is 4. 5 times negative 2 is negative 10, plus 6. 4 plus 6 is 10, minus 10 is 0. So that worked. And what about negative 3? Negative 3 squared is 9. 5 times negative 3 is minus 15. Plus 6. 9 plus 6 is 15. Minus 15 is equal to 0. So we can see that it worked for both of those. So zero product property is valid. It's usable. We can do that. Well, what else can we do while I fight with getting this red marker off the board, right? We can try a couple things, and I'm just looking over to some reference, some things that I have here. Well, what if we try something a little more complicated than this, and we have 10x squared plus x minus 2 is equal to 0. Well, how are we going to factor that? Well, I don't have a leading coefficient of 1, so personally I'm going to go for factoring by grouping. All right, so 10 times 2 is negative 20, so I want two numbers that multiply to negative 20 and add to 1. That should be pretty straightforward. 5 and 4 will multiply to 20. And if I'm going for positive 1, then we're going to make the 5 positive and the 4 negative. So 5 and negative 4. So now I can break this up. I've got 10x squared plus 5x minus 4x minus 2. Remember, it's still equal to 0. We're just factoring with that. So now 10x squared plus 5x, I can factor out 5x. And that leaves me with 2x plus 1. And then I've got negative 4x minus 2, so I can pull out negative 2. Leaving me with 2x plus 1. That's a good sign because we came out with the same value in the parentheses. So we have 2x plus 1 times 5x minus 2 is equal to 0. Don't forget my 0 back there. And now I can set each of these equal to 0. 2x plus 1 equal to 0. 2x equal to negative 1. X equal to negative 1/2. And for the other one, 5x minus 2 is equal to 0. 5x is equal to 2. And x is equal to 2/5. So what's our solution? X equal to negative 1/2 and 2/5. And again, we can go through and plug those back in to verify that that works. But that's our idea, is we can factor our quadratic and solve using the zero product property. Okay? Another property that we may want to use is the square root property. Now the square root property, we've mentioned it a little before in passing, just of how you have to deal with square roots. If you have x squared is equal to a, and we want to solve for x, we can take the square root of both sides. So x is equal to the square root of a. But we have to remember that it can also be equal to the negative square root of a. We talk about the primary root and the negative root. So it could be either one. So we would actually say if we have x squared plus a, we would say that x is equal to plus or minus the square root of a, whatever that happens to be. So that would be our standard process. So whenever we're dealing with these in factoring quadratics, if we end up with this square root, we have to take the square of both sides and it takes the square root of something. Don't forget the plus or minus, because if you do forget it, you're going to lose one of the possible factors. So if I modify this slightly and say, okay, x squared is equal to 9, then x is equal to plus or minus the square root of 9, thus x is equal to plus or minus 3. And obviously if we plug 3 in, 3 squared is 9. If we plug negative 3 in, negative 3 squared is 9. So that works. So that's the basic idea of it. So let's take one a little more interesting and see if I've got one down here. Let's just do x squared is equal to 29. Okay? So not that complicated. X squared is equal to 29. We're going to take the square root of both sides. X is equal to plus or minus the square root of 29. Simple enough. Now at times we may want to find this to the closest hundredth or whatever, but I would generally just leave it like that unless we need to get an actual value. If this came down to a question where we were saying the area of a square is 29, what is the length of one side of the square? Well then, remember the area of a square is just the length of the side squared, because all the sides are equal, so side times side, or in this case x times x, x squared. So if we take the square root of that, that's going to give us the length of a side. Obviously, we can't have a length that's negative, so in that case, since we're dealing with a real-world situation, there's a restriction on what x could really be. But there are many other things that we could deal with where x could be a negative number. So this is a valid root. But when we're working on real world problems and word problems and such, we do have to look at the boundaries of that problem and see, is that a possible answer or not? Okay, let's try another one. Just a slight modification on this. Well, if we have x squared is equal to negative 144. Now remember I said when we're factoring these and trying to solve for it, we need to have 0 on one side of the equation, so we're going to add 144 to both sides, so we get x squared plus 144 is equal to 0. Okay, so we got x squared plus 144 is equal to 0. Well, that's fine, but do we know of a way that we can factor this? I do recognize something. I recognize that if I make x squared, and then I make this minus negative 144, try to get my pen to write 144, sometimes it has a mind of its own, is equal to 0. Now I can treat this as a difference of squares. Well, we know that 144 is a perfect square. Negative, we'll see, but what happens here? If I turn this into if I treat this as a difference of squares, I can actually write that as a product and a difference. So I can say x plus the square root of negative 144 x minus the square root of 144. X times x is x squared. X times negative, sorry, gotta put my square root, my negative inside here, right? X times negative square root of negative 144 gives us minus square root of negative 144 x. x times positive square root of negative 144 gives us square root of negative 144, x, those cancel out. Then the square root of negative 144 times the square root of negative 144 gives us 144, which means we're good. So we can set these each equal to 0. X is equal to, or I can say, we've already got that, so pull that over to the other side, minus negative square root of negative 144. And x is equal to positive square root of negative 144. You pull that, so we have plus or minus, so I'm just going to write that as x is equal to plus or minus the square root of negative 144. Well, if you have a negative under the radical, you pull that out as an I. So x is equal to plus or minus I square root of 144. Square root of 144 is 12, so x is equal to plus or minus 12i. Now, you may look at that and go, well, wait a second, Mr. Davis, why didn't we just take the square root of both sides? If I take the square root of both sides, I have x is equal to plus or minus the square root of 144, negative 144, and we pull that out, that's I, and it comes out 12i. Well, why didn't I? Because I wanted to show the process here and show what it was happening, that it was actually breaking it up into this sum and difference. So could you have done that? Yeah, it would have saved you a lot of time too. But it was interesting to see this process and see we come down to the same thing in the end. Okay, one more thing I want to do. Try another example here. Just to add another thing in here. So x minus 8 squared is equal to 24. Now, actually, let me rewrite that 4 so it does not look like a y. I just want that very clearly to be a 4. So we've got x minus 8 squared is equal to 24. Don't fall into the trap of going, oh, this is already factored, I just need to set each of these equal to 24. You can't do that. It's the zero product rule, which means it has to be equal to 0. So what I need to do is I need to square this to get it into quadratic form, and I need to move that 24 over. So first I'm going to square this. It's the square of a difference, which means I can square the first term, remember those special products, x squared, I can do plus 2 times the product of the two terms, so minus 16x, because you have minus 8x, gives you minus 16x, and then plus the square of the second term, negative 8 times negative 8 is plus 64, is equal to 24. Now I can subtract 24 from both sides. X squared minus 16x plus 40 is equal to 0. So now I'm at a point where I can start to solve it. Right? I put it into the form of a quadratic equal to 0. Leading coefficient is 1, makes my life a little easier, so I want two numbers that multiply to 40 and add to negative 16. So they're going to have opposite signs, right? And they're going to multiply to 40, add to negative 16. So what can I get out of that? Oh, if you do 4 times 10, that'll give us 40, but that's going to give us 6. What about 2 times 20? No, that's not going to do it for me. Any thoughts on this? Let's look at that. Drop my paper on the floor. Oh, don't get old. It's not fun. So I look at this and go, boy, why did I do that? I'm not finding anything that gives me, that multiplies to 40 and adds to negative 16. So what am I going to do? Well, what I'm going to do is I'm going to go back to, rather than doing this, I'm going to just bring that over. X minus 8 squared minus 24 is equal to 0. Well, what does that do for us? We can turn this into a difference of squares. X minus 8 squared minus the square root of 24 squared is equal to 0. Well, if we have a difference of squares, that's the product of a sum and difference. So I can say that's x minus 8. I'm going to put another bracket here, plus the square root of 24 times x minus 8 minus the square root of 24 is equal to the 0. So I've got this product of a sum and a difference. So now I can make this x minus 8 plus the square root of 24, x minus 8 minus the square root of 24 is equal to 0, and I can start solving for x. So x minus 8 plus the square root of 24 is equal to 0. If we add 8 to both sides and subtract the square root of 24, we get x equal to 8 minus the square root of 24. If we go x minus 8 minus the square root of 24 is equal to 0, then x is equal to 8 plus the square root of 24. Now, we can do a little bit more here in simplifying, because 24 is 4 times 6. 4 is a perfect square. So we can take it one more step and say x is equal to 8 minus 2 square root of 6, and x is equal to 8 plus 2 square root of 6, giving us a final statement of x is equal to 8 plus or minus 2 square root of 6. So that was a little more complicated than we were hoping for. So what happened? We had x minus 8 squared is equal to 24. At first we tried bringing it over and turning and seeing if we could factor by grouping. We found we couldn't. It wasn't a nice factoring thing. It didn't work. So then we said, well, what if we brought this over and we said, well, that's a difference. Let's turn it into a difference of squares. So we took the square root of 24 and squared it, which is 24, right? So we broke it in. Now we had the difference of squares. Well, then the difference of squares is just the product of the sum and the difference. So we were able to pull that out. And then we just started solving each of them. And when we got done, we found out that we had this same constant term, the same whole number term here, right? Integer 8. We had the same term with the radical in it, 2 radical 6, but one was plus and one was minus. So we had 8 plus or minus 2 radical 6. Came out to be our final result. So sometimes we have to try more than one way to get there, but we can do it as long as we keep these different things in mind. And I know that it gets confusing at times. You look at this and go, oh man, there's so many options. And in mathematics there are so many options. Sometimes you just have to try a few and say, well, what happens if I do this? What happens if I do that? Can I do this to it? Try it. Can we factor it normally? Can we factor by grouping? Well, we can't do that. Well, what if we try this and we say, well, what if I turn it into a difference of squares? Well, I can do a difference of squares, and then I can work. It still doesn't come out to anything pretty. You can't really simplify this anymore. 8 plus or minus 2 radical 6. Radical 6 is an irrational number. So we can't do anything more with that. We can't multiply that together unless we're going to round. We can't factor out that 2. It doesn't really help us. We could turn it into 2 times the quantity 4 plus or minus radical 6, but that's making it more complicated instead of less complicated. So it may take a little bit of work. We may have to play with things a little bit, But try a method, try another method. If it doesn't work, try another method and see what you get out of it. Okay? So that's going to be the first part of working with quadratic equations.